In this short lecture module, we'll go over another example of our generalized effective decision procedure using Venn diagrams to evaluate a direct inference in both the Boolean and the Aristotelian interpretation. In the next lecture module, we'll turn our attention to translation heuristics. So let's consider a second argument. In this argument, I have as a premise all round squares are black squares. And as my conclusion, I have some round squares are black squares. Again, you might want to stop the video, try to execute our effective decision procedure, determine whether or not you think this argument is valid or invalid in both Boolean and Aristotelian logic, then start the video and see if you get the same answer that I did. As before, we'll begin by creating a premise and a conclusion diagram. Our subject class, always on the left-hand side, we take a letter that represents the subject term and label that subject class with that letter. Same thing for the predicate class, always on the right-hand side of both diagrams. Take a letter that represents that predicate term, use it to label our predicate class. Our premise says all round squares are black squares. So we're being good Booleans. I don't know if there are any round squares. Don't know if there are any black squares. But here's what I know. Everything that is in that R circle would also have to be in that B circle. All the R's are B's. And therefore, area 1 there, the far left part of my Venn diagram, that would have to be empty. There can't be anything there if all of the round squares are in the black square circle. So I shade it, and that is what minimally has to be true under that Boolean interpretation for my premise to be true. Now let's look at my conclusion diagram. My conclusion says some round squares are black squares. There's at least one thing, call it X. It is a round square, it is an R, it is also a B. So it would have to go in the area of my diagram where it is in both circles. So it goes in the intersection there, the area 3, the overlapping part. And now I have what minimally has to be true in order for my conclusion to be true. Now I want to evaluate it for Boolean validity by looking at my conclusion diagram and saying, okay, I need at least one X, at least one thing in that area 3, in that intersection area, in order to guarantee my conclusion is true. I look over at my premise diagram. All that my premise diagram guarantees is that that far left side, R and only R, has to be empty. It doesn't guarantee anything about the rest of the diagram. There's nothing written anywhere else in that diagram, and so it's possible for the premise to be true without guaranteeing that the conclusion is true, and therefore this argument is invalid in Boolean logic. Now I want to evaluate it for Aristotelian validity. I don't have to worry about the conclusion diagram. I don't have to worry about the predicate class of the premise diagram. I only have to focus on the subject class of the premise diagram in these direct inferences, and I have to ask, does that premise diagram show that that premise class satisfies the Aristotelian assumption? Is there an X somewhere in that subject circle of my premise diagram? And there isn't, so I'll put one in the only area where it can go, in that intersection area there, and I'll say, okay, I'll circle that X because I want to remind myself I'm only entitled to suppose that there is something in that intersection on the Aristotelian assumption. Now I want to use those diagrams, make my comparison again, and make that initial evaluation of Aristotelian validity. So now I look at my conclusion diagram. At minimum, what I need in order for my conclusion to be true, there has to be at least one thing, call it X. It has to be in area 3 in the intersection there. I look over at my premise diagram, and now I say, okay, I've got a circled X right there in that intersection. There's at least one thing in that intersection between R and B in my premise diagram now, such that if my premise is true, I have everything I need to make my conclusion true. But before I rush into saying that the argument is valid in Aristotelian logic, I have to check to see if it commits the existential fallacy. So now I go back and I look at my subject class and I say, does my subject class actually satisfy the Aristotelian assumption? Is it a good Aristotelian category? And I look at it and I go, okay, round squares. Well, no such thing. If you're a circle, you're round. But if you're a square, you cannot be round. Therefore, that class has no members. And as a result, it cannot be valid in Aristotelian logic. Instead, it commits the existential fallacy.